Okay, today's lesson, as we're starting statistics, is about box and whisker plots. So let's go ahead and look at this. You should take notes on this. The median is a statistical term that separates the data into two equal parts, which means 50% of the data is below it, 50% is above it. The data can be further separated into quartiles. The quartiles separate the original data into four equal parts, as a quartile means 1/4. Each of these parts contain 1/4 of the data. So in box and whisker plots, data is organized and displayed by dividing a set of data into four parts using the median and quartiles. You can go ahead and probably what you really need to write down for your notes is the first quartile is also called the lower quartile. It's the first 25th percentile. The second quartile is also called the median. It's where 50% of the data is above it, 50% is below it. The third quartile, or the upper quartile, is where the 75th percentile. Interquartile range is the difference between the upper and lower quartiles. So IQR, the abbreviation for interquartile range, is equal to Q3, upper quartile, minus Q1, lower quartile. If you have a small interquartile range, that means your data is close together. If you have a large interquartile range, your data is more spread out. Outliers, that's data that's more than 1.5 times the value of the interquartile range beyond the quartiles. So let's go ahead and look at this example here. The first quartile is at 4. The least value, which is also called the lower extreme, is 0. The median is at 10. The third quartile, or the upper quartile, is at 17. And then the upper extreme, or greatest value, is 45. So here we have an example of a box and whisker plot. And now this lower one, with comparing Class A and Class B, that is a double box and whisker plot where we can compare them. You can see that Class A is more spread out. This has nothing to do with the number of students in each class. All it is their data summarized into box and whisker plots. So according to the box and whisker plot shown below, what's the third quartile? So you're looking at your lower extreme, your Q1 or your lower quartile, your median, and then here is your Q3 or upper quartile. And then 100 your upper extreme. So 90 is the correct answer there. What does this box and whisker plot tell you about the data? Well, this is a height spreadsheet. We'll be doing one of these in class. The left whisker is longer than the right whisker, so the data are more spread out in the first quartile. The median class height is 64 inches, which is 5'4". And the range of the data is 72 minus 50, which is 22 inches. So there's kind of a widespread height. According to this box and whisker plot, what are the 5 statistical summary values? Well, you look at your median, which is 80. Your first quartile, 70. Your third quartile is 90. And your minimum value, or your lower extreme, is 65. And your maximum value, or upper extreme, is 100. So when you look at this one, the little scenario is the number of iTunes downloaded by 25 students in 1 week ranges from 15 to 55. The box and whisker plot depicts this data below. So look at this. What's the minimum number of iTunes anybody downloaded? Well, you can see that would be the lower extreme, which is 15. The maximum number of iTunes downloaded would be 55. It's that upper extreme. What's the number of iTunes at the 25th percentile? So the number of iTunes is 20. And all you know is that 1/4 of the students downloaded that or less. No, downloaded 20, sorry. What's the number of iTunes at the 50th percentile? It's 25. And the number of iTunes at the 75th percentile is 40. And you can see the top half of the box is more spread out. Therefore, that's a bigger range. Okay, so if I identify the outlier here, remember what's the definition of an outlier? It's 1.5 times the interquartile range. Here the interquartile range looks like at about 94 to 63. And so you take that, you make it 1.5 times that, and this is below that. So that's an outlier. So when you want to go ahead and make a box and whisker plot, you can go ahead and do this paper and pencil. We'll be using the graphing calculator in class. So you take all those numbers, and there's 15 of them, and add them all up. Then you divide by the number 15. And that gives you your average. But the other thing we can do is take it and think, okay, 1, 2, 3, 4, 5, 6, 7, 8. There's 7 numbers above 10 and 7 numbers below 10. So that we know that 10 has to be the median. Well, that pretty much gives us the right answer right there, because that's where, that's the only one that has 10 as the median. That is the middle number, and that's going to be 50% above, 50% below. So here is a double box and whisker plot, and it compares your class to your friend's class on this particular test score. So let's see which statements are true. Half of the test scores in your class are between 85 and 100. Well, between 85 and 95 is 50% of your class, not 100. So that one's not true. 25% of the test scores in your friend's class are 80 or above. So 25% is right here. That's not an 80, that's a 70. Alright, medians are the same for both classes. Well, that's not right either. This median is at 90 for your class, and this median is at 80. And the test scores in your friend's class are more spread out than the test scores in your class. Definitely true. Because as you can see, your box and whisker plot is very spread out. Even your upper and lower extreme, much more spread out. So would you please write down your comparisons of this problem and the next problem? Please bring these to class.